I'll record this as well, so that way I'll post it online and people can see the solutions to E6 in the event that you need to revisit this. Per usual, my strategy is going to be fill out this table and then punch in the numbers. Now, what I see here is a parallel branch inside of a circuit that's mostly series. R's 1 and 4 are series with the battery. Anything that passes through the battery will pass through R1. So anything that comes through the battery has no choice but to go to R1. Now we get to the split here. That's why 2 and 3 are parallel, because you're choosing path 2 or path 3. Regardless of what you choose, you will rejoin at that second blue circle and you will go through R4. So I am going to view the circuit: one resistor, second resistor, third resistor. And I know this resistor is 2 and I know this one's 4. So let's see, what is this one here? Okay, so we'll go 1 over 6 plus 1 over 12 equals 1 over R. These numbers work out so nice. 4 ohms. Okay, 1/6 plus 1/12 is 1/4. You do the reciprocal of 1/4, you get 4 over 1, or more commonly called 4. All right, so total resistance 4 ohms. Let's fill out the given information first. 2, 6, 12, 4, 120. And what we just did is we got 10 ohms total. 2 plus 4 plus 4. Okay. Questions thus far? Cool. All right. So we're going to use V equals IR, and then we'll use P equals IV, but we'll save that one for last because I always just do power last. 120 equals I times 10, so I is 12. At 12 amps going through the battery, they have to go through R1. They have to go through R4. So 12 and 12. V equals IR, 12 by 2 is 24. 12 by 4 is 48. That tells me, hey, here's R1, burn 24. R4, burn 48. What does the battery do? Add 120. And a question I often get asked a lot, hey, you know, how come this line next to the battery is always 0 volts? Because the whole idea of the battery is taking 0 volts and raising it to, well, whatever voltage you want. In this case, 120 volts. That's the purpose of the battery. If there was no battery, everything would be 0 volts. We would have nothing, no voltage supply. Okay. So we got 120 volts. And what we first see happen is a resistor burns 24 of those 120 volts. It's going to leave us with 96. Now, voltage does not split, because voltage isn't actually a flow of movement. It's a quantity of energy possessed over a given amount of charge. Don't confuse that with the energy itself. I can tell you this line's 48 volts because 48 volts, the current carried 48 volts through R4. R4 burned 48 volts and we're left with 0. Okay. So that's my trick for figuring out that R's 2 and 3 both consume 48 volts. Why? Because we went from 96 down to 48. So this one took 48 volts, this one took 48 volts. But why didn't they share? That's not how voltage works. The current gets split. The 12 amps gets split. It gets split 8 and 4. So 12 amps came through this intersection. 8 of them chose R2. 4 of them chose R3. That makes sense. R2 is half the resistance of R3. So it would probably get twice the traffic as R3. Electricity is going to favor a path of least resistance. It's like a 8th semester senior, okay? Path of least resistance. P equals IV. Here's what we crack out a calculator. Let's see, I think 12 by 24 is 288. 8 by 48, that's 384. Geez, 48 by 4, 192. 48 by 12, 576. 12 by 120, that's 1440. You can check these numbers, boom, 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 you add them together. They will come out for sure to equal 1440, which means you consumed 1,440 joules every second. You also produce 1,440 joules every second. All right, questions on this one?
I have a quick question about the current. I don't know, I'm kind of just struggling. Like, I get how to find the total resistance and then how to use like total voltage to find the total current, but I'm a little confused how you like find the rest of the currents besides like R1 because like that's connected to the beginning.
So R1 and 4 are connected to the battery directly, so that's why they get the 12. As for the 8 and 4, I actually didn't really figure out how much went to R2 and how much went to R3. I basically solved for it mathematically. So what I did was I used as much information as I could about the total current, figuring out what R1, how much voltage it would be, R4, how much voltage it would be. But then when the current split, I stopped using current to solve this chart. That's when I switched over to voltage. Because the current, I mean, is there a way to figure out? Yeah, there is. It's difficult. It's actually not too bad on this one because you have a resistor of 6 and a resistor of 12. So one of them is exactly double that of the other. So that means the current's going to be double on R2 that it would be on R3. But you know, what if you have like 7 and 9.5? You're building a ratio, and that gets really annoying to deal with. So instead, what I did was I figured out what was the voltage drop across R2 and R3. That's how I got 48 and 48. Now, how do I get this 8 and 4? 48 divided by 6 is 8. And 48 divided by 12 is 4. So the mathematics and the logic have to align together in order to do this. Does that answer the question? Or?
Yeah, thank you.
Okay. And you'll see it again as we go into the next example of that one's even trickier, the current. Last call on this one before it goes bye-bye. Okay. So again, I'm going to fill out this chart, and I'll use the chart to answer the questions. I didn't answer the questions in the last one, but it would work. I promise. All right, so what just happened? 240. Okay. Yeah. All I've done is put in the given information. Think of your circuit as having very similar to the previous one, where you have 4 resistors in this parallel branch. But MJ, there's 5 resistors. There are. Yeah, I see that. But let me tell you something about these two right here. It's very simply, if you go through R2, you must go through R3. So those two resistors are in series with each other. Okay. So what I'm going to do is I'm going to say 15 plus 45, that's 60. All right. You can't choose R2 and be like, nah, I'm good. I'm going to skip R3. No, that's not possible. In circuits, these are one-way roads. It's kind of like saying you're going to drive past the Starbucks at the corner over there, but you're not going to drive by the Pizza Popolis. Yeah, you are. You don't have a choice. They're connected. Okay. Nope. I'm going to stop my car, get out, and destroy it right there on the road. I'm not passing by Pizza Popolis. What? No, that's weird. If you drive by the Starbucks, you've also driven by a Pizza Popolis. Makes sense? Current goes through R2, it means it also went through R3. Now it's just like the circuit we did last time. So let's add this parallel branch. 1 over 60, 1 over 20. Oh, these are beautiful numbers. R comes out to 15. How did he do that? 1 over 60 plus 1 over 20, common denominator 60. 1 over 60 plus 3 over 60 is 4 over 60. Reciprocal of 4 over 60, 60 over 4. 60 over 4 is 15. Or you could just use a calculator too. This is not a math class, it's a physics class. We're not weird like that. Now, you won't always have a calculator with you. That's what I was told. You won't always have a calculator with you wherever you go. Are you sure about that? Yeah. Oops. All right. Enough of my ramblings. Now I need more room. My circuit is effectively a 3 resistor series circuit. Okay, I have 5, I have 15, and I have 10. 5, 15, and 10, that's going to give me 30. Now it's time to run some V equals IR. 240 equals 8 times 30. Eight amps. 8 amps come from the battery, goes right through R1, reaches this intersection and splits. Eventually, it will rejoin down here. The 8 amps will keep on moving through, keep going, keep going, keep going, get to R5. So that's an 8, and that's an 8. There are questions before I go on. Okay. By now, you should feel pretty confident. And, well, the first step, once you get your total current, total resistance, is what else shares that total current? Well, anything that's in series with the battery. So that'll be R1, that'll be R5. All right. V equals IR. V equals 8 times 5, that's 40. V equals 8 times 10, that's 80. So drop 40 here and drop 80 here. 0 volts. 240 volts. How I know 0 and 240? That's the whole concept of the battery. The battery takes 0 volts and it raises it to 240. Boom, boom, plus 240. 0 plus 240 is 240. So this line's 240. And then this line, after we cross this resistor, 240 minus 40, this one's 200. All right. This one, 80. How do I know that? I'm just playing this one in reverse. I have 0 after a resistor that consumed 80. So I bet I had 80 before that resistor. Like walking out of a store with no cash in your pocket, but you have a receipt that says you spent $80 in cash. Well, I bet that means you walked into the store with $80 in cash. The same deal here. We have no voltage after the last resistor. And we do know the resistor consumed 80 volts. So I bet we had 80 volts on the line leading up to it. So R4 bridges 200 down to 80. So that's 120 volts. R's 2 and 3 combined do the same thing. So I can say this. And if we get into more complex circuitry, we'd actually be using that technique a lot more. Don't worry, we're at the top for regular physics. You want to get into more complex circuitry? Come join me in AP1 next year. All right. So this kind of leads into, I don't know which Washington it was, but one of them asked, so how does this current thing work? That is we're at that point right now. So what we have is we have 8 amps coming into this intersection. Now, how much goes down here and how much goes this way? Well, that's what the chart's going to help me out with. 120 equals 6 times 20. So just doing V equals IR, I figure out that, well, 4 amps, 6 amps have to make their way to R4. So 8 come in, 6 go this way. So safe bet, 2 went this way. 2 by 15, that's 30. 2 by 45, that's 90. 30 and 90, that equals 120 that I predicted would be there. It's like magic, except it's real. So it's called science. P equals IV. 40 by 8 is 320. 30 by 2, that's 60. 90 by 2, that's 180. 120 by 6, that's 720. 80 by 8, 640. 240 by 8, 1920. There we go. Success.